Hi, this is a short video on adding decimals. And the first one we're going to start out with is the following decimals: 8 and 6/10, 23 and 1/10, and 92 1/100. So normally, we tell students, okay, this is what you do. You line up the decimal points, and so all of the place values in the right spot, and then you go ahead and add those, right? And we have our different algorithms. We have left to right, right to left, partial sums, all that sort of fun stuff. But why do we encourage them to do that? Why do we encourage them to line up the decimal points and then add those place values together? Well, it's basically for the same reason that if we were just adding whole numbers together, let's say, for example, 23 and 8, right? We would do the same thing. We line the units places up under each other. If there were tens places, you'd line them up. So the same sort of reason we want to do that here. But how can we illustrate that? Okay, we can do that in a couple of different ways. The first way is that we're going to write these as individual fractions, right? So 8.6 or 8 and 6/10 is 8 plus 6/10. 23.1 or 23 and 1/10 is 23 and 1/10. And 0.92 or 92 1/100, we can break that down as 9/10 plus 2 1/100. And then from there, we can go ahead and see that we add, then just like with fractions, right? You add fractions with like denominators, and you can see the place values we're adding together, right? So if we take that in context, so there are 0 1/100 here and 0 1/100 here. So 0 plus 0 plus 2 is 2 1/100. Okay. And now we've got 6/10 plus 1/10 plus 9/10, which is 16/10, right? And then we've got 8 plus 23, which is 31. But 16/10, we're not going to leave that as 16/10. We want to convert that. That's equivalent to 1 and 6/10, or think of that as 1 plus 6/10. So that 1 is now a whole number, right? That's a whole 1. So 31 plus 1 is 32 and 6/10 plus 2 1/100. So our final answer is 32 and 62 1/100. Now if we compare that to our algorithm that we had mentioned earlier of lining up the decimals and adding, what happens there? We can backfill these zeros as placeholders, right? And then we get a 2, and then 9 plus 1 plus 6 is 16, and we make the exchange, right? There's our one whole, there's our one unit, right? And then we add those together to get our 32.62 or 32 and 62 1/100. Another version that we can do showing this with doing it with fractions is the following. So if we take 8 and 6/10 and convert that to a fraction, right? 8 and 6/10, in particular in proper fraction, that is 86/10, and we convert 23 and 1/10. 23 and 1/10, I'm going to make that a mixed number. That's going to be 23 times 10 is 230 plus 1, 231 tenths, and 0.92 is 92 1/100. So now if I add those together, I have 86/10 plus 231 tenths plus 92 1/100. So in order to be able to add those together, they have to have a common denominator, right? So the common denominator, the largest one we have is 100, so the other two are 10. So we have to do a little bit of multiplying in both the numerator and denominator in each. And then we can go ahead and add them all up. And if we notice what happens if we add, now we're just adding whole numbers, right? So this is 860 plus 2,310 plus 92 out of 100. And if we add up those whole numbers, that numerator, that turns into 3,262 over 100. And guess what that is as a decimal? That is that decimal. Okay, so that's another way to look at these decimals in terms of fractions and adding. So the next thing we're going to take a look at is with using basically the base 10 blocks, right? We had talked about if we let the flat equal 1, then the long equals a tenth, and the little cube, or the dot in this case, equals 1/100th. Okay? So if we represent this addition problem, 3 2/10 plus 2 39/100ths, we would get the following, right? So we have 3 units, so that's 3 flats, plus 2 longs. And then we have 2 flats, plus 3 longs, and 9 units. So if we add them all together, we have our 9 units still, and we have 2 longs plus 3 longs is 5 longs, and then we have a total of 5 flats as well. So this is 5 units, 1, 2, 3, 4, 5 tenths, and 9/100ths. And you can also see if you end up having to make an exchange, right? If you have 10 of the little units, you make an exchange for a long, and so on and so forth. So all the same strategies we had from before still apply.